Assalamualaikum. I am Sumbul Zehra from Sir Syed Government Girls College. With the support and guidance of our Principal Professor Khalida Parveen, today I am here again to give lecture on Bio Sawart's law. But until now, I hope you all have subscribed this YouTube channel, which is Sindh College Lecturers YouTube channel. Today we will discuss Bio Sawart's law. So far, we have studied that if a charged particle is kept in a magnetic field, it experiences a force if it moves. If it does not move, there will be no force observed. But what we are discussing is magnetic field. So, who creates this magnetic field? The source of magnetic field. That is our topic today. So, when there is a moving charge, there is an electric current, and this electric current is the source of magnetic field. Now, if electric current is our source of magnetic field, then how much current gives how much magnetic field? We know the intensity of the magnetic field is defined as 1 unit of Tesla, that gives 1 Newton force to 1 coulomb charge that moves with a velocity of 1 meter per second. There is a force 1 Newton, then the intensity is 1 Tesla, but who creates this 1 Tesla? So, the current creates this, the moving charge creates this 1 Tesla of magnetic field. So, what is the relation between strength of the magnetic field and the quantity of the current? If here current is flowing I, how much is the current I so that the magnetic field is 2 Tesla? What is the relation between intensity of the magnetic field and the electric current which is creating this magnetic field? For this, first time the law was made by Bio Sawart. Bio Sawart's law tells us the relation between few quantities. These few quantities are the strength of the magnetic field created by current. So there is a current and there is a magnetic field. For that, we can take an example. We have taken a conductor, a small element of a conductor from which current I is flowing. If there is a current, there is a certain magnetic field. So we have taken one point P and there is a magnetic field created here. How much is the magnetic field? From that, for that he made a law. He says that the source of the magnetic field is electric current. But here we defined that for flowing of magnetic field, the length has to be there. If there is no length, then how current will flow? A charge, unless a charge moves, it cannot make electric current. So for making electric current, the charge has to move. If it moves, then there is some length of the path. Unless the length of the path is there, charge cannot move. If it does not move, it does not form current. If it does not form current, it has no velocity. There will be no magnetic field. So what is necessary is a charge length of the path is necessary and the charge must move. So combining all these things, moving charge makes current length of the path. A very small length element dl is taken. When the charge passes through it, it forms a current because it is moving now. This current can create magnetic field all around it, and we found out magnetic field at this point P. So what is the speciality of this point P? This point has specification in two terms. What is the distance of dl from point P and at what angle it is? We can call this length element dl as current element, and all such small elements put together makes up the conductor. So this current element is the preliminary thing which is responsible to create magnetic field. So magnetic field is created by this current element. This current element which creating a magnetic field, so we can find out the magnetic field at point P through this current element. So this point P is at a position R, making an angle theta with dl. Some magnetic field is produced here, so the strength of that magnetic field is dB. So now there is a current element dl in which current I is flowing as shown in the diagram. There is a point P which is at a distance r, and this position vector making an angle theta with the current element dl. So now we are calculating the magnetic field at point P. For this, Bio Sawart makes a law. He says dB is directly proportional to IDL. Magnetic field is directly proportional to current and is also directly proportional to current element. If current element is larger, then strength of the field increases. If current is larger, then also strength of the field increases. And strength of the field means magnetic field is inversely proportional to the square of the distance. The more will be the distance, the weaker will be the force dB. Here he calculated that the strength of this magnetic field will decrease as square of the distance. So as we said earlier, that dB is inversely proportional to 1 over r square, which is just like same as Coulomb's law. And this magnetic field dB is affected by theta. If theta equals to 90 degree, then field is maximum. If theta equals to 0 degree, then field is 0. And that change is according to sine theta. Magnetic field at all distances is not same. It is affected by angle also, and this dependency is dB is directly proportional to sine theta. Now combining all three relations, then dB is directly proportional to IDL sine theta upon r square, where IDL is the current element, means source of the magnetic field, and theta is the angle between position vector r and current element dl, and it is also inversely proportional to the square of this position vector. So this equation of Bio Sawart law is very much like Coulomb's law, where E equals to 1 upon 4 pi epsilon naught q over r square, where epsilon naught in Coulomb's law is the permittivity of the medium, which is the quantity gives certain electrical characteristics, whether it allows the charge to apply force on it or it will not allow the charge to apply force. There is another property in space which allows magnetic field to be applied, and this characteristics of space allows that how much magnetic field at this point P is given. So with this property of space is known as mu naught, which is known as permeability of free space. If there is a material medium, so we cannot take it as mu naught, we can take it as only mu. So in Bio Sawart law, if we replace the proportionality, there is dB equals to 1 upon 4 pi mu naught IDL sine theta upon r square. So this is known as Bio Sawart law, and this dB is the magnitude of field which is creating at point P. So now we have taken out the magnitude of this magnetic field by Bio Sawart law, and now we are taking out the direction of this magnetic field by right hand palm rule. As shown in the diagram, the two fingers of the right hand are showing the direction of the position vector r and the current element dl, and thumb is in the direction of the field, which is in the inward direction, and the direction of this field which is inward is shown by the cross as shown in the diagram, above diagram. So now we are taking out the unit of permeability of free space. So mu naught upon 4 pi equals to 10 raised to power minus 7 units, means mu naught equals to 4 pi into 10 raised to power minus 7. Now dB has a unit of Tesla, so put in the units in equation of Bio Sawart law. So dB as a unit Tesla into meter square, R square as a unit meter square, divided by ampere, and dl has a unit meter. So mu naught has a unit Tesla meter ampere inverse. Because 4 pi is constant, so unit of mu naught is Tesla meter ampere inverse. Right. So that's all for today. Thank you so much.